Okay, so we want to talk real quick about the difference between permutations and combinations. So we have permutations here. Versus combinations. Now, the thing you hear thrown around a lot is, does order matter? If order matters, we say that's a permutation. Well, what does that mean when order matters? Consider this example. So I said, I'm going to throw a house party. I'm going to invite everyone from class. There's going to be a bunch of people there, and I'm going to give out door prizes. Okay. So I have 3 different door prizes. I'm going to pick one person randomly from my party. Okay. Maybe just everyone puts their name in a hat. I pick one random person. The first person I pick, we'll consider that third place. Doesn't really matter what we call it, but they get a $10 gift card. Second person I pick, they're going to get a $50 gift card. And the third person I pick is going to get a $100 gift card. Now, depending on whether or not I picked you first, second, or third, that's going to change the outcome. Okay, you winning $10 is different than you winning 50, which is different than you winning 100. So in this particular case, the order in which I pick will matter. It doesn't just matter that you won one of the 3 prizes. It also matters which prize you in fact did win. Now, if I said same situation, but now my door prizes are going to be $50 gift cards, 3 of them. 3 people each get $50. So in this case, it doesn't matter if I pick you first, second, or third. You are either just a winner or you're not. So in this case, this would be a combination. Here, the order you're picked matters. Here, the order you're picked does not matter. Okay. So another way you can think of it as, are the things that I'm choosing distinguishable from one another after they're chosen? So here I've chosen 3 people. Yes, the person I picked last is distinguishable from the person I picked first. Here I've chosen 3 people. I don't know which one I picked first, second, or third because it doesn't matter. They all get the same thing. So if I apply that to some of the examples from the math, if I said, and it might take a little bit of thinking for some of these, but it says, suppose a designer has a palette of 6 colors to work with and wants to design a flag with 4 vertical stripes, all of different colors. So in this case, does the order in which he picks the colors matter? Okay, if he has 4 vertical stripes, right? There's your 4 vertical stripes. 1, 2, 3, 4. Does the order in which he picks the stripes matter? Well, yeah, well, changing the order of the colors will change the design of the flag. So in this particular case, order matters. So choosing blue here or blue here will create a different flag. So it's going to be the number of choices we have, 6 permute the things I'm choosing. So this will be 6 permute 4, which you can find in the calculator, but it is 360. Okay. Moving right along. Person is going to a party is asked to bring 3 different bags of chips. Going to the store, she finds 15 varieties. How many different selections can she make? Well, let's just say the chips she decided to go with were Doritos, Fritos, and Takis, right? If she picks Doritos first or Doritos third, it doesn't matter. She's bringing these 3 brands of chip. So the order she picks them doesn't matter. You don't know when she shows up to the party which one she picked first or last. So here, order does not matter. So this will just be the number of choices we have. Choose the number of things we are choosing. That will give us 455. Order does not matter. And how many ways can first, second, and third prizes be awarded to a contest with 545 contestants? They should do a better job specifying, but we can just assume that first, second, and third prizes are different. So you winning third is different than you winning first. So this is going to be order matters, 545, permute three things, whatever that is, you'll put that there. And how many ways can 3 books be chosen from a group of 9? Doesn't matter which book you choose first, which book you choose second, or which book you choose third, as long as they're either chosen or not. So order does not matter. That's 9, choose 3. How many ways can 5 DVDs be arranged on a shelf? Whenever you see arranged, that kind of signifies that order matters. Okay, the arrange changes, the order changes. So order is important here. So this is going to be 5, and we're going to permute all 5, which you ended up getting, which was 120. Okay, a swim meet consists of 2 teams, each with 8 players. This is like intentionally confusing. At the end, each player gives a high five to all of their teammates, as well as each of their competitors. So the teams don't matter. There's just 16 people. There's 16 people. After all the high-fiving is finished, how many high fives have occurred? So you have 16 people. The order in which you high-five another person doesn't matter, just as long as everyone gets high-fived. And this is kind of an interesting example, but if I have 16 people and I want to count up the number of high fives, you're just counting up the number of ways I can pair 2 people. And each pairing is going to result in a high five. So this is really just 16 choose. I'm counting the number of ways of selecting groups of 2. So this is going to be 16 choose 2, which I'll do that real quick because I have this up. That's going to be 120. And hopefully that clears things up a little bit.